everybody, and welcome to another episode of Adventures in Machine Learning. This week on our panel, we have Gant Laborde.
Hey.
Eric Chalmers.
Hello.
I'm Charles Max Wood from devchat.tv. I'm just going to do a real quick plug for Max Coders. It's a platform about building the skills that are going to help you have a successful career in life. You can check it out at maxcoders.io. You can kind of think of it as soft skills stuff is what we're talking about, though I am going to have some tech stuff in there as well. So go check it out and see what's offered there. We have a special guest this week, and that is Jason Antic. Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on. It's done with experts from companies like Google, Microsoft, Amazon, and Apple. And it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml. And that'll take you to the right place so you can sign up for the course. Jason, do you want to introduce yourself?
Yeah, hi. So I guess the best way to introduce myself is I'm the guy who made this thing called DeOldify, which is this really popular deep learning based tool to colorize images and video. And I did that last year, and I've been working on it ever since.
Nice.
Yes, that is awesome. That's an example that, like, I see everybody showing. They're like, "Look what machine learning can do. Here you go. Here's the photo. Now look at it. Woo!"
It's too bad this is a podcast, really, because you really have to see this to get a sense for how cool it is, right?
Yeah, go look it up.
We'll put some links to it in the show notes where you can watch some of it. But it's interesting too because this is somewhat, in my mind, along the lines of what we expect AI to be able to do, I think, as we learn more about it. And I'm waiting for the couple of things where, people just come in and it's like mind blown. It's like, I didn't even think computers would ever come up with that. So, but yeah, this is really interesting. And I'm curious how it all works. Do you want to talk a little bit about how you came up with this idea and then walk us through the process of building it?
Yeah, sure. So last year, I took Fast AI. Fast AI is this online MOOC for deep learning. And it took about 3 months to get through parts 1 and 2. And then after that, I just wanted to do a capstone project. And I had a list of 15 different projects that I wanted to do. And one of them was this sort of shower thought I had where I thought, hey, I wonder why people aren't doing this yet, where you take a GAN and try to train a neural network to colorize well. Because up until this point, colorization just didn't work very well. It was pretty dull and not too impressive. So GANs had this promise of being able to do things much more realistically. GANs standing for generative adversarial networks. So I got to work on that after my courses were complete, and it took about 6 weeks between August and September last year. And I was wrong a lot, but eventually I was right. And I was hilariously wrong at first. It was really bad looking. And when I posted these photos on Facebook as I was progressing, people really were wondering what the hell I was thinking. But I was.
I don't know. I've been to that part of Willy Wonka's factory, so.
But yeah, I was seeing little signs of progress here and there, and then eventually, just one day, it actually really worked, and
wow.
I got excited about it, and I immediately went to Reddit and posted the project on the machine learning subreddit, and I didn't think it would get as much attention as it would, but the next day, I found out that Cory Doctorow from Boing Boing picked up the story, posted about it, and then at that point I was like, "Oh crap!" Because I knew at that point it was going to go viral, and it did, and I started getting a lot of attention for it. So my life changed ever since. And I wasn't even planning on working on the project that long. I was going to do 6 weeks, if that, and then move on to other things. But this just really caught on. And then I've been actually just obsessing over it ever since, well over a year now.
Wow, what an amazing world with this new technology, where you get a shower thought and it's just next thing you know, that's that's the thing that's catching on. I want to rewind a little bit for some people coming in here. So some people might be very familiar with GANs. They might be really familiar with a lot of the concepts, but I want to just do a quick elevator pitch and talking about some of the concepts here. So one of the things that somebody might say is like, oh, you have these colored photos, and then you take the color out of it, and then you're telling the machine, hey, figure out how to put the color back in. And then you apply a GAN to that. Which, by the way, since my name is Gant, it actually always stood for Generative Adversarial Network Technology. I just don't know if I knew that. But I guess like you took it to the next level of sort of like having the discriminator and the governor working. Can you just take a minute and break down that sort of that sort of process of how you get some data, how you were getting it in there, and then elevator pitch it to us, so that way anybody who's new to this can know what to go Google?
Sure, I'll do the best I can. So, as far as the data is concerned, it's a very simple idea. You're just taking modern photos, like let's say ImageNet. I mean, ImageNet's like a huge data set of like 1.4 million images, I think. So you want that magnitude of images. And they're all, just modern color images. And what you do with them is you say, okay, that's my target. Now I need to create the before images, the black and white images that you're starting with. So you just convert them to grayscale, and you do other things like mess them up a little bit, like make the resolution a little bit worse, add a little bit of noise and stuff like that. You're trying to simulate what an old photo is, right? Because that's what you want your neural network to do. You want it to fix that. So that's your data. And then the next component rather is you mentioned the GAN. So first, just a neural network in general, like if you were not to use a GAN, you would just have a one singular generator model. And that generator model would be trained directly to colorize images. And, like I mentioned before, that doesn't work as well, but you could still do that. The GAN idea is that you take another model called a critic, which will look at real color images versus the ones that the generator is generating and figure out which one's real and which one's generated. And what you do with that is you have the critic give feedback to the generator every time it's evaluating these before and afters, or these, the generator versus real, and use that to train the generator, because the critic's going to tell the generator just how good or bad those generated images are. And in turn, the generator gets better and better and makes the critic work harder and harder. So they have this feedback loop, where they go back and forth teaching each other. And that sort of competition or adversarial, if you will, situation produces really good results. It's a little bit wonky. I mean, it tends to go off the rails a lot, but when it works really well.
That's a great explanation. Thank you. I think that helps a lot of people sort of understand how you get a ridiculous amount of information and then have it work so well.
Right. And then the adversarial part of it is the, kind of the one-upmanship between your critic and your system.
Yeah,
right?
Correct.
Mm-hmm. But Jason, you kind of took a new approach in that you didn't use a straight GAN, right? You kind of trained each part separately first. Could you provide a little more detail on that?
Yeah, so that's a very interesting thing to talk about. So originally when I worked on DeOldify, I just started with training the GAN from scratch. So the original DeOldify was just doing GANs the way they're normally done, which is you have the generator that doesn't know what the hell it's doing at the beginning, and you have the critic that doesn't know what the hell it's doing at the beginning. So the generator will start by generating noise, and the critic will start by not knowing that noise is any worse than real images, right? So that's actually how GANs usually are trained. And when I saw this situation, I was just thinking like, wow, that seems like a really bad idea. It's like, because I don't know, it just seems like you're setting up the GAN for failure, right? It's kind of like, would you have like the blind leading the blind, right? Like, why would you do that? So, this is a big thing from Fast AI. Jeremy Howard, who teaches the course, has been a real pioneer in this thing called transfer learning. And it's one of the things that you really take away from Fast AI is the power of transfer learning. And he's the guy, by the way, that really got transfer learning to be popular in NLP and natural language processing. So now that we see these language models like BERT and GPT-2, these incredible models that really work well, and they didn't before, that was transfer learning. And you see transfer learning in computer vision as well, and so on. So, it's a very powerful thing. And up to this point last year, when I was looking at DeOldify back in, let's say, November at this point, after it was initially released, transfer learning just wasn't being done for GANs, and I just didn't know why. So at that point, Jeremy and I were working together on course material because he saw my work on DeOldify after I released it and contacted me, and he wanted to incorporate that into his lesson 7. So we got to work on that. And I brought this up to him. I said, hey, do you think we could do transfer learning for GANs? And we had a 2-week window to work with, by the way. and he's like, yeah, sure, let's do it. And so we did it. and we did it in 2 weeks. I was really proud of that. So we wound up calling it NoGAN. So the reason why we're calling it NoGAN is this is a special kind of GAN training. So what we're doing here with the transfer learning part is that instead of starting off your generator and critics as feral children, right, when they start teaching each other.
I have 5 of those.
They don't know anything.
Not no GANs.
You give them an education first, right? So you teach the generator in a traditional, more controllable way, and take it as far as possible, which you can still take it really far. You can get it to the point where it's generating okay images using traditional methods. You just can't get it all the way to GAN quality, right? So you do that. And then the critic, you can then train by looking at what that okay generator generates and comparing that to real images. And you train the critic as what's called a binary classifier, which is a very basic kind of neural network, very easy to train. So you're just saying this is, you're asking it to distinguish between real and fake. And then finally, after all that, you finally put them together, and then you train them as a GAN. And what's really cool about this situation when you train them like that is, first of all, because they don't have garbage, that the generator's not generating noise, and the critic knows better than to think that noise is awesome. That seems to go a long way to making the results a lot cleaner and better and reliable. So your training starts on a much better start. The second thing is that the whole process of getting much better results from the GAN training part happens incredibly quickly, and that's really the surprising part. So my F8 talk that I did in May about the video functionality, I demonstrated that the desirable part that you're getting from the GAN training, where you're going from a dull image to like very colorful, was taking like 10 minutes of GAN training.
Wow.
And that's after like you're doing like a day or so of all that pre-training that I just described. Yeah, that's the GAN transfer learning idea in a nutshell. And again, that's called NoGAN.
Yeah.
Very cool.
That is so cool, man. So I guess I want to ask 2 different questions now.
Yeah.
First one I want to ask, just for everybody, is so how long ago did you start taking the course and start actually jumping in full force into AI? Was this something you're always interested in, or did you take the course and then get excited?
Yeah. So this is okay. So I kind of want to help other people out there, because like I definitely tried multiple times on this path, and I rage quit quite a few times before I actually stuck with it. Because I had to say, at least a few years ago, I don't know what it's like now, but I got interested in deep learning years ago, like actually even in college. And, this will age me a bit, but, back in the mid 2000s, I was actually interested in neural networks even back then. And I was very surprised that they didn't even like teach them in my courses, because I took a computer vision course and a artificial intelligence course in Penn State, and they didn't cover that stuff at all. So neural networks were definitely not in fashion back then. But, I was paying attention when deep learning came around in 2012. And, I started trying to take, the courses that people were recommending. I won't name names. I don't want to name any particular ones. But I can just tell you there were quite a few popular ones that a lot of people talk about that I tried and I just couldn't get into, or honestly, I got bored, or some of it was, the math was a little too much too fast, and a lot of it was just poor course structure, and it was a lack of time too, really, because you're trying to do this on top of like working, a software developer job and all the other stuff you're supposed to do. So back in like 3 years ago, I started taking the first version of Fast AI, and that actually stuck. And I loved it. And
good. Yeah.
Yeah. It was just a totally different experience from anything I tried previously. The only problem I had with it was, I still had to put in a lot of time for it. So I was like taking vacation days just to learn it. Then I just kind of realized how crazy this was. And I was like, okay, I need to actually set aside even more time for this. So I actually planned like a year ahead of time to actually go part-time at work and then dedicate a whole bunch more time on this stuff. So that's what I did. And then back last year, I went full-time, like almost full-time on learning Fast AI, version 2, part 1 and 2 last year. And summer of 2018. And still, and this is something I want to emphasize, is it was like still like 3 months of solid, coursework, even with all that extra time. And then that capstone project that turned into like my obsession that I'm still working on to this day. So that's how I got into
it. I just want to call something out here. And this is me on kind of the kick that I've been on lately, working on Max Coders and everything else, is you really wanted to learn it. You wanted to go out and do it. And a lot of people would just feel like, you know what, I have to hold down my job. I've got all these other responsibilities in life, and there's just no way. And instead, you just went after it. And I applaud you for that, because, there were plenty of reasons why you couldn't do it. And you went for it anyway because you wanted it.
Yeah. I know not everybody can do what I did. I just want to make that clear.
Oh, fair. But...
Yeah, because like I have a wife that is very tolerant, quite frankly.
The secret behind every excellent coder.
Yeah. And yeah, I can't understate that enough. There's quite. I just have to emphasize there's quite a bit of privilege there coming into that. I had a good reputation at work, so not everybody can go part-time either at their job, and I know that. You have to be pretty established and be able to negotiate that. But yeah, it definitely wasn't easy, even with all that privilege.
Well, I really appreciate you sharing this information with everybody. And I think that like mediums like podcasts, you've definitely been putting a lot of great information out on Twitter. It's definitely not been something that you've hoarded or kept to yourself. It's something that it looks like good people want to share. So kudos on that. Even if it was hard, it looks like you're sharing DeOldify with a lot of people, and then also continuing to make it better and share that with the community as well.
Well, yeah, thanks. Yeah, I just, really, I kind of share Jeremy Howard's mindset on this stuff, which is I really like the idea of democratizing deep learning. And so, I think there's a lot of components to that, just first of all, just really encouraging and letting people know that, no, you could really do it, because I'm not particularly special myself. I'm not, I only have a bachelor's degree, in computer science. And I up until this point, I was working in a cubicle in insurance company as a software engineer for 10 years. And it was exactly like you imagine it, which is, like office space, right?
I have to say I have a special place in my heart. I worked for an insurance company at computer science degree to go work in the tech department of an insurance company.
Really?
Yeah. I have to say open source for open source and just sort of like open technologies finally gotten me out of there.
Yeah, no, that's the thing. Yeah, that's what got me out too.
Yeah,
actually,
that's good. That's awesome, man.
Yeah.
Not that there's anything wrong with insurance companies, right? I work for an insurance company.
Oh my God. What is happening right now?
It's all good.
There's nothing wrong with insurance companies.
True.
There's nothing wrong with insurance companies. Please keep paying my
No, that's exactly it.
Charles, we found out who still works for the insurance company.
Hey, I have a question for you, Jason. Just for people who are getting into this, can you talk a little bit about the hardware requirements? I mean, were you using kind of off-the-shelf hardware to train these things, or did you have access to a deep learning machine of some kind?
Okay, so I want to be honest about this because I up until this point, I've only advertised that I work with the GeForce 1080 Ti, right? So technically that's true. This DeOldify will run on a 1080 Ti. You can train it on a 1080 Ti on a normal gaming PC, basically, with Linux on it, of course. Now, that being said, when I was looking into doing this stuff, I realized that there's a lot of value in having more than one GPU if you want to do experiments. And that really makes all the difference in terms of how much progress you can make. So I have a beast of a machine in my dining room, and it heats up the whole house. It has 4 GPUs. It has 4 1080 Ti's and like 128 gigabytes RAM and a Threadripper with 32 cores. So that's actually what's running this stuff. And it's always running really hot. And the electric bill is really high all the time.
So instead of
that's
mining...
what we call efficiency, right? Because it heats the house. With a white noise machine.
Right.
If you lean against it, you get a little bit of that nice...
Yeah.
So Bitcoin's going to go up in value, and then Jason's going to be like, DeOldify, get a lot of money.
Exactly.
No, it's actually kind of funny because I live in San Diego, and the one thing you kind of lack around here, and this might sound really weird, but is climate control. So if you want heat, you have to have a space heater. So this is actually like great for the wintertime. I'm really looking forward to it.
Okay, I'm gonna run DeOldify and put my feet on the
Yeah. No, seriously, it's so hot. I have water cooling on it too, and it still gets really hot.
Jason, I want to ask you, you kind of threw out there about DeOldify and F8. You talked about it going to video, right?
Yeah.
And so I want to just ask a question. As someone who's never kind of seen something go from stills to video, did you have to adjust the process to like remove some kind of flicker? Like, would there be all of a sudden, or did it just like work?
So, okay, this is such an interesting story, I think, anyway. It's kind of hard to remember what things were like before you actually solve the problems, but I'll try to recount the best I can, which is, as far as I know, I think most people had the same assumption that I did before I actually solved this problem, which is that video required temporal modeling, meaning that you had to reduce inconsistencies between frames by making the model make explicit notes of what frame came before and what came after, and making sure that those frames were consistent, right? That's called temporal modeling. And so when just thinking about that, what immediately would curb my ambitions for doing any sort of work on video, because it's like, oh wow, that's way harder, right? I thought anyway. Then this guy from Arizona, Robert Bell, he started messaging me on Facebook and sending me these videos that he did with DeOldify. So he just took FFmpeg and shredded videos and then colorized individual frames with DeOldify. So it's just the normal image colorizing DeOldify that I put out there that he's doing this with. And I looked at him and I was like, wow, okay, they kind of suck like I expected, right? So they're all like flickery and inconsistent, and you totally cannot really watch them comfortably. But then, I took a closer look at what was actually happening, right? And I was like, oh wow, wait. So if I just make the colorizing process really, really good on individual photos, all these problems would actually pretty much go away, right? Because that's really what the problem was. So actually, this is actually where NoGAN came from, because because we did the initial work in November, but it wasn't on like video. It was for training like super resolution on images. It was just something we threw into the lesson 7 of Fast AI. But then when these videos started coming to me and I was starting to think about the problem, I was like, well, okay, so what I really need to do here is figure out how to stabilize GAN training. And I think if I do that, I'll solve this flickering problem. And so I was thinking about the no-GAN work we did, and I was like, I bet, if I really focus on it, I could get this to work. And that's what I did. Now there was just, a lot of surprises along the way, and that's kind of what's been interesting about this whole process over the past year is like, these things that are figured out, they tend to be these weird observations that you make that you have to pay attention to and then just act upon them and not disregard them. So, the videos that Robert Bell was sending me, that was the first thing, I had to pay close attention to and realize what was actually going on. And then the second thing was I didn't actually know that no-GAN trained so fast. So for a while, I was doing this no-GAN training, trying to get the videos to colorize well, and I was failing. And I'm wondering why. I was still getting like pretty bad results, even with the transfer learning for GANs, no GAN training. And then I slowly started realizing that, wow, you know what? Actually, if I really look closely at these results, I'm getting some surprisingly impressive results, like within the first 1,000 iterations of training. So I had to take a closer look at that, and it basically looked like at the very microscopic level of like per iteration, where is it actually going bad? And then so I finally realized that there was just like inflection point that up until that point, no GAN training was awesome, and then it diverged. So that's how I figured it out. And again, it's just these weird things that come up that you just have to when they don't meet your expectations, you take a closer look and you act upon it. Because I could have easily disregarded that and just chalked up what I was experiencing to as like, oh well, this just doesn't work. Because in a conventional sense, based on the expectations of what I learned up to that point, what I would have expected is that more training is better. Mm-hmm. Right?
Yeah.
like 1,000 iterations should definitely not be enough, right?
So what is the word for that in GANs? Is it still like overfitting or high variance or whatever? Like, is it still that same concept? I think.
Or is it just the like the stochastic gradient descent thing where you end up not ever finding the global optima, but kind of bouncing around it?
That's right. Yeah. So it has a lot to do with. I've learned ever since that if you increase the batch size, that helps a bit. Because what happens is it bounces around and like the result you'll see from a high level is like it's like a sine wave of good bad. But that sine wave. That's interesting. Yeah, the sine wave only starts after a certain point. So you want to get to that. You want to stop right at that point where the sine wave begins, because you can. So the thing that drove me nuts when I was trying to figure this out was like there seemed to be no rhyme or reason as to where the good result was and where the bad results were. But then I finally figured out, and this just took a lot of observation, that it was like a sine wave. Like it was actually just going good bad. Part of that, I was training on a batch size of 7 on this. Which is pretty low, especially for a GAN. I mean, there's this thing called Big GAN, and they tell you that, you get much better results if you have like a batch size of like 1,000 or something like that. But I'm working with very limited resources here, right? That's kind of an interesting thing too, is trying to work within those constraints on a desktop computer. You can do it. It's just a lot harder. Yeah. So, go ahead. Sorry.
We need to forever call that the sign of madness.
No, but that process you're describing, where you're experimenting with things and noticing and discovering, like that, to me, that's what makes deep learning so exciting. I mean, like I'm by no means a deep learning expert, but I get the sense that it's not an exact science yet, and there is still a lot of just kind of pushing into the frontier, finding out what you can do, what works, what doesn't, and then trying to find out why. Like it's a very exploratory process, which I think is cool.
Yeah. I mean, there's that's the positive way of looking at it. Like, so I got to tell you too, like, just to be brutally honest here, like, I'm coming from a software engineering background, and what I really like in hindsight about software engineering is that the problem solving has a beginning and an end. Where like, I'm really good at that, right? Like, I'm really good at narrowing down the search, and that's how I do problem solving. I treat it like a search problem, and that it has to be within this certain time and space, so you figure that out first, and then you just whittle it down until you get to the answer, and that's a very reliable process. I'm very good at it. But with deep learning, it's when you get ambitious anyway, you're trying to do stuff that's not been done yet, then yes, charitably speaking, it's a science, it's a process of discovery, and that's exciting, and it's great when it works, but it's a lot of dead ends, and a lot of self-doubt, and a lot of being wrong. And that's probably the hardest thing about it, is just at least from, I'm describing my own experience here. It's going to be different for others depending on what you're doing, but the ambitious stuff I'm trying to do, I'm wrong all the time. And that's so a lot of what in my opinion makes or breaks the whole process, as to whether or not things get done, has a lot more to do with tenacity and your ability to deal with getting your ego hit over and over again on a daily basis.
Yeah, absolutely.
So how much of it then feels like a black box, and how much of it feels like something you can actually get in and debug? Because essentially you're handing it a model and you're training it, right? So you don't have observable models. You look at the results and decide if they're good or not, right?
Yeah, that's kind of an interesting question, I think, because you want to treat it as much of a not black box as possible, because then
you have control.
Yeah. I mean, but that is kind of an illusion, honestly. But yeah, it's kind of a mixed bag. Like, I'm still learning along the way, like, as to what exactly is effective and what's not, because I have to. But the one thing I do know that you really need to do is set up feedback mechanisms. Like, TensorBoard was one of the first things I did, and where it's displaying the images that are being generated. Like, I have it displaying every 50 iterations. That really helps. But I also make it a habit of, like, if I'm seeing a glitch, I'll print out like different layers, like what the max number is, so you can narrow it down. Okay, that looks really strange, and then you're just looking at one layer, and you say, okay, probably multiplying way too much, or needs normalization or something like that. So that's how you break through the black box a little bit. And then I know there are ways of visualizing this stuff. I know there's some other things I could do, which I'm not doing. But, I also got to say, a lot of it is just a lot of guesswork on my part at this point. I don't know how much of it has to be, but that's, again, where I'm wrong a lot, is where you try to look at the model and really reason about it, and what's going on. And sometimes I'm right, but a lot, or seemingly right. And I got to emphasize that like it's always your mental idea of what's going on in a model is also a model, right?
And well said.
Yeah, and that should always be evolving, I think. Yeah, so that's basically my experience on it. It's definitely mostly a black box.
Yeah, it's funny. We're in that world where you're printing out logs and you're guessing what's happening. I feel like this when I start most new programming languages. And then eventually, hopefully, more tools come around. TensorBoard's a fantastic one. Google's actually got a lot of good debugging tools, I'll have to say, especially around this field. I'm looking forward to see what people come up with.
Yeah, I think there's definitely still a need for that, for the tooling. There's been a lot of progress on it, but yeah, I think that's where a lot of low-hanging fruit and a lot of potential productivity gains are going to be found, honestly.
I'm curious, what third-party tools? I mean, GANs mentioned TensorBoard, and we've heard TensorFlow mentioned a few times. Are you using TensorFlow or some other third-party systems or libraries to do this?
Oh, I'm actually using so the FastAI library is what I'm mostly focused on, and the FastAI library wraps around PyTorch. And the reason why I use
okay.
the reason why I use Fast AI is because it basically encodes a whole bunch of like things that should be no-brainer best practices. Like things like augmentation of your images, and the exact set of magical combination of defaults that generally work really well for certain training scenarios. Just all sorts of things like that. I'm definitely a big believer in automating away that sort of stuff as much as possible, so you can focus on bigger and better things. But at the same time, they really have a good philosophy of saying if those defaults aren't correct, you're free to customize the code, which I've also done. A lot of, actually, especially lately.
I was hoping you were going to say you used Fast AI because it was fast, but
It is actually. That's the amazing thing about it too. It is as advertised. They've made a lot of progress. Again, it's a lot to do with transfer learning and stuff like that. But one of the first lessons that you take, it actually is the first lesson, is classifying dog breeds. And I know that trains really fast. I forget exactly how fast that trains, but like I know the cats and dogs classifier that they had when I took it is like 5 to 10 minutes of training on a desktop. So this stuff is, I have to emphasize, it's very doable on the desktop. Even like the stuff I'm working on, it is state of the art. Impressive stuff.
So it's not just a witty name; it actually is fast.
Oh yeah. And actually, another thing to point out there too is they have actually done things like broken ImageNet training records in terms of.
Wow. Okay.
Yeah. So in terms of like the amount of time to train, so they've put a lot of emphasis on that. So if you're looking for speed, that's a good place to go too.
I think you might be talking me into it.
So here's maybe more of I don't know if it's a theory question or what, but in your GitHub, you talk about how if something goes wrong, it's usually like orange skin or what you call zombie hands, where the skin's mostly fine, look gray or whatever.
Yeah.
So like
I've
those are
seen
things
orange skin
that
on TV.
True. So I wonder, like those are things that we as humans, we look at that and just know that it's wrong, right? We know that skin isn't supposed to be gray and it's not supposed to be orange either. How do you build in like a bit of human knowledge into deep learning? I know there's this whole school of thought that says you shouldn't try to do that, but are there ways in your opinion that could be done?
Oh boy, dude, that's a great question. Okay, so that's multi-level because first I'll tell you one of the reasons why I went with GANs or DeOldify was for that reason, because that was in my mind the best bet for capturing those sorts of nuances, right? Because one of the big things I emphasized in my FA talk about this was that figuring out a loss function that captures the stuff that's important to human eyes, when we distinguish what's real and what's not, is very difficult, right? To actually formulate in practice. I just said, I simply don't know how to do it. So that's the idea behind GANs, is that, the real big thing in my mind is that they actually learn the loss function for you. Meaning, because I can just tell you, I've been asked this over and over again. Well, can't you just compare pixels to pixels, right? And I'm like, no, you can't. That'd be like MSE loss or L1 loss or whatever.
Yeah.
And I'm like, no, you can't, because what that leads to is encouraging the neural network to cheat. It'll look for those average numbers, those average colors that fulfill the requirements that you are putting on it. So,
interesting.
So it's kind of like when you force schools to achieve a certain standardized score. And for their students, they teach to the test, right? They cheat, and that's kind of like what happens with simple measures in general, right? When you have simple measures, you get simple results. And so with the case of like image colorization, you get brown and green and blue because they're common and they're easy and they're average, and they score well according to the metric that you're supplying, but it's a bad metric. You don't want that. So the idea is that the GAN can find that loss function for you and formulate that for you essentially. And it does that in my mind. It's just the major downside is that it takes a lot of extra memory in your GPU, and still to this day they're still very unstable. So that's the trade-off there. That being said, I still take it one step further, because that's still not enough. I would just simply argue you can't completely automate this yet. So the thing that's been driving me nuts for like the past year is that in order to really track progress on this stuff, I simply have to look at TensorBoard constantly and compare generated images over and over again, because there's just stuff that won't be caught otherwise.
Interesting.
Yeah.
So is this all written in Python, or is it written in some other language?
Python. Yeah.
I still love Ruby, and I'm still waiting to be able to do this with Ruby. But
oh man, everybody take a drink. I miss Ruby too.
I know, right? I'm not holding my breath.
No.
I don't know if there's any Swift fans out there, but Fast AI is working on being written around Swift now. It's being written on top of Swift for TensorFlow.
Wow.
Yeah.
Nice.
Yeah, the idea there, I know they're trying to make it so that you can really peer deep into the neural network in terms of debugging, because up until this point, it's very much a black box once you get to the NVIDIA software, and so, basically that's one of their goals there, is to be able to really like treat every step as a debuggable step.
All right, you talked me into it. That's it. I was looking, I was either going to go after reinforcement learning, or I was going to go after something else. Now I'm taking the Fast AI course.
Yeah.
Don't worry, it's fast.
I can't talk them up enough, honestly. I would also say that another great thing about them is that they do very broad coverage of materials, and I find that hugely beneficial, because I think it was briefly alluded to. I forget what the context was, but these different subfields in deep learning seem to have little to do with each other, like maybe NLP versus vision and stuff. But actually they do, in my mind. And actually, I think, for example, again, like vision was doing this transfer learning stuff for the longest time. Mm-hmm. And then Jeremy Howard finally brought it to natural language processing, because they just weren't doing it, and it revolutionized the field. So I really think that broad view of the whole field that they teach at FastAI is hugely beneficial, because that transfer learning stuff was like obvious to us. He brought it up like even before he did it, and we're like, yeah, of course you should do that. Why not? And he went ahead and did it. And so the rest is history. And I've had similar insights on other stuff that I've been wanting to try, just haven't been able to try yet. Actually, even GANs, I was really surprised that you didn't really see like GANs with UNets. UNets being the image-to-image networks. So yeah, just really surprised like how little left hand talks to me,
I think that's all of machine learning right now, right? You've got some people are just rewriting the same exact thing in a new programming language, right?
Yeah, right.
Have all these, and I refer to it as like there's all these islands and there are no bridges. So information sort of like gathers up on one island, and then finally someone builds the bridge, and then that's what happens. There's just this sudden, amazing connection. And I feel like there's quite a few of those that are going to happen over the next 5 years that are going to change the hell out of what it is that every developer is doing in the next 10.
Yeah, no, I totally agree with you on that. I think that's where the low-hanging fruit probably is at this point in the field.
Well, and we've seen this over and over and over again. I mean, history, I heard somebody say history doesn't necessarily repeat itself, but it rhymes. And we see, new technology or new scientific breakthroughs or whatever come out. And then somebody goes, oh, I guess if that's true, then this must be true too. Yes. And then we start having all these big leaps forward. So, something's going to come and break loose here with some of this stuff. And it's just a matter of time. And some of it's, we're going to see it and we're all going to go, that was obvious. And then some of it's going to be, why did we've been staring at this for 5 years. Why didn't we think of that? And then some of it's going to be, just kind of oh, wow, that was beautifully simplistic. And, we just never would have gotten there unless we'd had this happy accident. So,
yeah, I'll just put this out there on the podcast for people listening because I keep wanting to put this thought out there and I just can't put enough work into it to prove it yet. But I'm a really big fan of self-attention, and that's what I use in DeOldify. And I've been putting a lot of focus on that, by the way, on my latest work, and I've been making a lot of progress with it. Like I've been seeing a huge amount of gains on it.
Mm-hmm.
I haven't been able to release it yet and show people, but I just want to put it out there that I really think that there needs to be more attention on self-attention. And because up till this point, as far as I can tell, all the attention on attention is in natural language processing for the most part. So you hear about the transformer architecture and all that stuff. But I'm really surprised, still to this day, that it's not like the standard in computer vision models. I'm very convinced that it's like the next logical step. So I'm just putting this out there for people who are listening. There's probably like a lot of low-hanging fruit right there. It's probably not hard.
Nice.
That was a good endorsement.
Yeah.
Yeah, and it may just take your set of eyes, your way of thinking about it, whoever's listening.
Yeah, seriously. I mean, yeah, that's the other thing too. It's like you might think that surely there's a lot of smart people in this field thinking about these things, especially in deep learning. Like, there's just so much money and so many smart people involved and big companies, involved. But it seems like actually in practice, it's just there's a lot of all these smart people focus on very narrow things.
Yeah. That's the classic strange thing. It's like we have these giant businesses, like they're coming up, they have teams of people, and so they're going to come up with all the great ideas, and then somebody comes out of the woodworks, it's like, hey, look what I built, and it catches on fire.
Yeah,
it's because like the big companies are like, nobody gets fired for saying we should go with IBM. Right. So like,
right.
You're not going to, it's a different architecture and the iteration, sort of like you having a computer in your dining room that's warming your house. Like none of those executives are doing anything close to that.
Yeah. Well, the other thing is that what I find is experience has the benefit of being able to weed out all of the extra stuff that they don't need to know in order to get whatever it is that they're getting done. And the difference is that, then you get some new person in who doesn't know that needs to be weeded out. They don't know that they're wrong. And it turns out that they're not wrong.
Oh, that's
yeah.
Well, the coolest part of what you've done, Jason, I think, is, in my opinion, is in challenging the assumption about temporal modeling in video. Like the fact that you can colorize a video frame by frame without looking at the previous or following frames. Like I wouldn't have thought that would work because I had bought into that assumption you mentioned that videos are inherently temporal and your model needs to have a temporal component. But blown that right out of the water.
Well, yeah, I mean, don't get me wrong. I mean, people will still rightly point out that there are some flickering issues with video, but they're a lot less than you would expect. And
right.
I still think the way forward is to make image processing better rather than focusing on temporal modeling. It was more like an engineering sense I was trying to bring to it, the problem too. Because, the whole tacking on a thing called temporal modeling to compensate for the lack of consistency just seemed really hacky to me. So I think that's another thing too with this field is I really think just good old engineering sense is a really valuable thing to bring into it right now. Like did PyTorch 1.3 just came out yesterday, and I was really happy about something I thought was so brain dead simple that they should have done a long time ago, which is this thing called named tensors, which is this idea that instead of having to put comments in your code describing what this index in the tensor means, like this is your set of color channels, and this is your height and width, and this is your batch size. That you just access this stuff by name, right? In the tensor itself. So it's like self-documenting code, which is a thing I'm really a fan of as a software engineer, because I think anything else, comments to indicate this stuff is just inferior, because those things can go out of date and be misleading, and it's just clutter. in the code. So that's, to me, that's like basic software engineering discipline that is sorely lacking right now in the field. And it's surprising, and in particular, because I know how much of a difference that sort of thing makes, right? Yeah, I think, again, it's really surprising, just how much low-hanging fruit there is still. And I think that's another big thing. That, and I would say along with that, I would say sensible tooling revolving around, software engineering of these machine learning models.
Yep. Are you DeOldifying full time now?
Oh yeah. I mean, I work 8 hours a week at that old job that I called Office Space. I think my boss will have a sense of humor about it if he ever hears that. I hope. Please forgive me. But yeah, the rest of the time is spent obsessing on DeOldify and being wrong all the time.
Nice.
And making small little progress here and there.
Fail the way to success, man. Fail the way to success.
Yeah, that's exactly. Yeah. You just have to be really comfortable with failure.
Yeah. Well, in a certain sense, you're either figuring out things that other people know, or you're inventing, your way to the next thing. So
yeah,
you have to fail in order to get there.
Yeah. You mentioned the whole lack of experience, to dismiss things like everybody else would, that sort of thing. And that's exactly where I'm coming from. So it seems like it's been beneficial so far, where I've been kind of delusionally ambitious on this stuff. Not to say no, that's wrong or stupid or impossible. I think I'll get there eventually. I'm going to have a whole bunch of hard set opinions about things, and then I won't be making any more discoveries after that. But
Yep.
But in the meantime, yeah, it's been driven by I just don't know better.
All right. Well, anything else that we should be talking about before we do picks?
I wanted to tell you guys about the really cool Metropolis remix video that came out, but that just got taken offline.
Oh, did it?
For copyright notice. Yeah.
Oh,
it did.
No. I hate that.
Yeah, I was kind of mystified by that because I thought it was public domain, but yeah, so it was. I can just tell you about it. It's one of the things I really like about putting this DeOldify work out there as open source, is that a whole bunch of people have run with this software and done some really cool things. There's some not so great things, but this was really well done. They took the movie Metropolis, because I've done demos on it in the past and shown that you could do scenes really well with it, with DeOldify, and they did the whole movie, and then they did dubbing on top of it. They called it Metropolis Remix, and it was just such a great, I would say nearly professional job that they did on it. I was really impressed. I was actually that was the height of my DeOldify adventure so far, honestly, seeing that happen.
Yeah, it was really good. I'm sad it's down, because I watched a good part of it, and that exposed me to the movie. I've seen people reference it and a couple other things, but I don't. What was it originally? German?
Yeah.
I don't speak German. You've got to really twist my arm and say this is going to be worth your time to watch an old black and white movie. But just the fact that it was recolored and it was in English, I wanted watching a good portion of it. And when I first saw that, and I know movie critics are of course going to be like, "Oh, you can't do that. It's so perfect. Never touch this." But it exposed me to something that I would have never actually had the opportunity to be interested in. And I'm really sad that they took that down. I hope that gets fixed and kind of put back up, because it's so cool.
Yeah, I mean, that's kind of the nature of the internet. I'm sure it'll find its way somewhere. Right. I don't think it's going away. And there's a lot of people who liked it quite a bit. I mean, yeah, you're right that there was a lot of people who criticized it.
Oh, movie critics. Yeah, they're going to, I don't know what else they can do.
right. Yeah, I mean, I'll just put this out there. My 2 cents on that is, everything that we do, every person ever, even the greats, they build upon the work that's done previously.
Yes.
It's a remix, it's a rethought. If you think it's original, it's not. you're putting a little bit of a creative spin on it. It's certainly true to DeOldify. I stumbled along the way, putting together old stuff and making something slightly new, cool. But you can't discount that it was like mostly definitely standing on the shoulders of giants. And that's what they did with this Metropolis remix. In my mind, it was a really awesome artistic effort, but there were a lot of people that were like, well, I don't know if it's a lot. It's more like the vocal minority, that makes it stink when things, and it's a very predictable stink about this stuff, which is to say vandalizing. That's literally what they would say there. You're vandalizing this guy's work, even though it's digital. It's not like they're like spray painting over the original. The original still exists. You don't have to watch this new one.
I don't know. Shake that paint can, right?
Right.
Yeah.
Well, Jason, I actually want to, as far as feel good stories go, our CTO of our company found a really old photo of his grandparents, and we ran DeOldify on it. And then our CEO, who really enjoys doing Photoshop, started with your template, and then with a fraction of the time, that it really would have taken from starting from scratch, he was able to choose the different portions and then fix it up really nicely. And we gave that back to him, and it's something I think he's going to print out and keep. And it's like, this is something that probably would have taken a lot longer or a lot of money, and now it's something that's going to be hanging up on a wall. And it's just like there's a lot of really cool benefits to this technology, and kudos to like releasing this out there and helping people out with this kind of stuff, because it's just, I think it enriches a lot of lives.
Oh, that's awesome. Yeah, thanks. I just say to that, I know DeOldify has been compared to like manual colorist, and people will point out that the manual colorists do a much better job, and I agree with them 100%. That I'll make. I'm not going to claim that DeOldify does anywhere near the kind of work that Marina or any of the other ones.
Well, price per second, you still win, though.
Yes, yeah, exactly. No, that's the whole point of it, right? It's like it's for everybody else, right? That's really what I'm trying to do here. It's like the 80% solution for way less than 20%, right?
Right. Yeah.
Yeah. Well, and sometimes it works out and you help people out, and sometimes the internet's just a generative adversarial network. Okay, I'm really going deep on these dad jokes. I think we need to start wrapping up.
Somebody reel them in.
All right. Well, I'm gonna kind of nudge us over to picks. Before we do that, Jason, if people want to follow you online, see what's going on with DeOldify, things like that, what are the best places to go?
So I have a Twitter account that I'm posting to all the time. That's primarily where I'm putting progress on. And sometimes I just go into these periods where I don't post anything on there because I'm working. But yeah, that would be CITNAJ, Sitnaj. It's my name backwards. That's my handle. There, of course, there's the GitHub, Jantic, JANTIC. It has the DeOldify project on it. And then I also post to YouTube with the same, I think it's the same handle. Anyway, if you search for DeOldify YouTube, you'll come across my account, my personal Jason Antic account on YouTube, and I post a whole bunch of stuff on there. But I'd say your best bet's Twitter.
All right. Well, let's go ahead and do some picks. Gant, do you have some picks for us?
Yeah. So recently, Google Developer Fest was here in New Orleans, and I got to have a really awesome conversation with Ikaba Bisong, who is a Google GDE in machine learning, and he wrote a book called Building Machine Learning and Deep Learning Models on the Google Platform. I guess they were paying him by the word, and that's why he decided to go with the title that long. But really, really, really awesome dude. He actually helped me for a little bit. I asked him to take a look at something on the course that I'm building for TensorFlow.js, and he put down everything and sat there and helped me try to find a bug. And I was just I mean, getting that kind of attention and care from friendly people is super cool. So absolutely, I bought his book. Next time I see him, I'm going to have him sign it. But I saw his presentation. He definitely knows everything he's talking about, and I can't wait to read his book. So building machine learning and deep learning models on the Google Cloud platform. So that's my pick because I know the author is a super cool guy, so the book's going to be awesome.
Very cool. Eric, do you have some picks for us?
Sure. I have a non-technical pick this week. I've just finished reading the book The Untethered Soul by Michael Singer. It's all about kind of like identifying and acknowledging our like inner fears and limitations and learning to transcend those things. I'm the kind of person who gets really fixated for long periods of time on like the technical aspects of my my job and interests. And this book is helping me to kind of realize more of a balanced approach to life. So I'd recommend it to anyone who's looking for that same thing.
Awesome. I'm going to throw kind of a different pick out there. I'll pick a book too, just for good measure. So I've been reading The 360-Degree Leader by John Maxwell. It's a terrific book. If you're a leader in a company, this one's geared a little bit more toward the leaders in the middle. So middle management. So you're not at the top of the organization and you're not at the bottom of the organization. So you're leading people below you and you're being led and hopefully leading people above you as well. And he talks about how to be a good leader, leading up, leading across, people who are your peers and leading down. It is a tremendous book. Here at devchat.tv, I'm not really middle management. I'm at the top of the organization because I own the company, but it's still given me tons of ideas on how I can better work with my team and make sure that I'm taking good care of them. And then at the same time, I'm probably going to have them read it so that they'll have ideas on how they can open the dialogue with me on things that, maybe they're not thinking about. I like to think that I'm pretty approachable. And for the most part, if they have ideas, I feel like they're bringing them to me, but, just give them other ways of reaching out and giving them ideas on how this can all come together. Really enjoying that. And then the other pick that I'm going to put out there. So this last Saturday, I can walk again now. I ran the St. George Marathon in southern Utah. So if you've never trained for a marathon, I will tell you it's an experience and it takes some time, but it's probably been one of the more rewarding things that I've done. It takes a lot of work. And when you get up to the starting line, at least for me, because it was my first marathon, the idea of being able to run a marathon felt impossible. But at the same time, I knew the road we were running on because I've driven it a number of times. And it didn't seem impossible that I could run down that road. And so, there was kind of this juxtaposition until I finished and then realized, I can run a marathon. And, the fact that I'd done it on roads that I knew, probably helped a little bit. But yeah, it was awesome. And so I really, really enjoyed that process. And, yeah. So finally, I'm also going to just shout out about Max Coders. This is, again, just helping people be successful in their careers and their lives. A lot of people focus on their technical skills, and those are important. But what I find is that a lot more leaders in companies are hiring for your ability to work on a team, your ability to learn things quickly, your ability to identify problems and then bring solutions. And so that's going to be the focus of Max Coders. And you can go find that at maxcoders.io.
That's awesome. So Max Coder sounds amazing. Congratulations on the marathon. That is epic. I know a lot of people who try that, and it just it's sort of like getting into machine learning. They have to try and then try and then try, and then eventually they get it.
Yeah,
and
push through the pain.
Yeah. As far as the 360 book, I only read books in radians, so I'm going to skip that one.
Okay.
We could just rebrand it as the 2-Pi leader, right?
Yes.
Yeah, there we go.
Oh, heart.
Yeah, Jason, do you have some things you want to shout out about?
Yeah, sure. I have a TV show.
You have a TV show? I'm impressed.
Recently I got into this show called Adam Ruins Everything on True TV, and I just love it. So the basic premise of the show is that they take a different topic every week and they ruin it, meaning they dispel myths that people commonly believe about this, that, or the other. And they cover a pretty broad range of topics. They recently I saw one on marriage, on death, on college, stuff like that. So yeah, what I really like about it in particular is that they really strike the balance of presenting genuinely good information, because the stuff I know about that they talk about, I'm like, yep. I'm glad you're talking about that. And there's a lot of stuff I don't know that they're talking about. And so it's like, you're actually learning something new, but they do a really good job of not only keeping it factual, but also keeping it really, really funny and entertaining. I'd say, I was looking for, like, I don't know, who's the next, like, James Randi, or who's some of the four horsemen, Daniel Denon and people like that. And I would say Adam Conover, the host of this show, is that guy. So I really admire what he's doing.
Yeah, that's a +1 on that. That's a great TV show. I will say that some of the episodes take me a little bit of while to agree, and some of them I never do.
Yeah, right. Yeah.
But it's pretty cool. Like, I've never even thought of some of those things. It's a great show.
Awesome. All right. Well, we're going to go ahead and wrap this up. Thank you for coming, Jason, and thanks to our panel.
Yeah, thank you.
All right. Well, we'll have another episode next week, and in the meantime, max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.